Hi, this lesson is on relating trig functions. So we're going to be looking at basically reciprocal functions, domain and range, signs of all the trig functions, and then the cofunction identity. So lots of stuff in this lesson, jam-packed. Recall from algebra that a reciprocal is a flipped fraction. Reciprocal. And I have talked a little bit about reciprocal functions in previous videos, so this will be a little bit of a review. Remember using the unit circle and definitions that cosine theta is x over 1, and then secant theta is 1 over x. Those are reciprocal functions because the fraction is flipped. So we can use that to kind of come up with not new identities, but just kind of rewrite our identities a little bit. These are reciprocal functions. So secant is 1 over cosine, cosecant is 1 over sine, cotangent is 1 over tangent. And then I did rewrite these using reciprocal functions too. One of the things I want to put here is that originally this was written as sine over cosine. So we could write this as cosine over sine. That's just another way to look at it. But anyway, we're going to use that to solve these two problems down here. If sine theta is 0.3, then cosecant theta is what? So we know that by the reciprocal function that cosecant is the reciprocal. So this would be 0.3 over 1. And if I were to flip that, it'd be 1 over 0.3 and then simplify. It's kind of a weird fraction, so I'm just going to multiply the numerator and denominator by 10, and that gives me 10 over 3. Then for cotangent theta is 4/3. So tangent theta, since those are reciprocals, we just flip it. And there you go. That's all at once. So this brings me to domain and range of trig functions. This is going to be very important when we get into solving trig functions later and determining, which solutions work. So we can think of trig functions in terms of input and output, where input is the angle, and then the output is the ratio of the sides, or the trig value for that angle, basically. And with that, we can fill in this table below I have of domain and range. I did put the unit circle here just for reference, because it's going to really help us narrow down that domain and range. For sine and cosine, if you think about that in terms of the ratios that we've been used to dealing with, sine is y over 1 and cosine is x over 1. Now, the issue here with domain is that we need to focus on the denominator. And we need to figure out if there's any issues that come up in the denominator. When I say issues, I mean if 0 is in the denominator, then that's a problem. It becomes undefined. Now, in this case, the denominator is 1 on both sine and cosine, and 1 is never going to equal 0. So the domain is fine for all real numbers. Nothing is restricted here. So I put negative infinity to infinity. It can be anything. And the range is restricted, if you'll notice by the unit circle. The highest the y value goes is 1, and the lowest the y values go are -1. So that's going to be the region where all of our sine and cosine values live for the range. Cosecant is 1 over sine. So I need to figure out, okay, what is going to make sine equal to 0? Because if it does equal 0, then I've got 0 in the denominator, and that's undefined. So I'm going to go up here and I'm going to figure out where sine is 0, or y, where y is 0. That is only here and here. Now, remember that those have infinite coterminal sides, so it could go on and on forever, but I'm just going to list a few of them to say for domain. I'm not going to use interval notation here. I'm going to simplify it a little bit. I'm going to say that theta cannot equal 0, 180, 360, and so on. Any multiple of those, basically. And that's going to affect our, cosecant is going to be affected by the range because, again, it is 1 over y. So if we were to look at a table of values here, I'm kind of going through this quickly just to kind of give you the summary here. I don't want to do a full lesson on it, but if you look at the table of values for cosecant, the cosecant of theta is going to be less than or equal to -1, and cosecant of theta is going to be greater than or equal to 1. So it's basically, if you think of, I'm doing this because I'm thinking of the number line in my head, the arrows are going to be pointing opposite directions from 1 and -1. Just an example there, if I were to do, let's say sine theta is 1/2. So if I were to do 1 over y, and then I simplify, I end up with 2, and that's bigger than 1. And that's going to happen with all of the y values for sine. So anyway, lots of algebra behind that. Secant, we need to focus on when cosine is 0. And we need to eliminate that from our domain. So we go up here and we see when the x values are 0, that is here and here. That's 90 and 270. So I'm going to say theta cannot equal 90, 270, and so on. For the range, it's a very similar concept. If we do 1 over every x value up here, same thing. If you do 1 over the x, and then you simplify, you would get bigger than 1. 1 over x, simplify, you get bigger than 1, and then we have the negative side. So it's going to be less than or equal to -1 and greater than or equal to 1. Again, same thing with the number line. The shading would go opposite directions, and that would be where our range lives. Now, tangent is sine over cosine. So again, we're focusing on cosine for our domain. We need to figure out where cosine is 0 and eliminate those as part of our domain. We've already done it in the previous box here, so we know that theta cannot equal 90, 270, and so on. Cotangent is the reciprocal of tangent, so we're focusing on sine again. And where sine is 0 is 0, 180, 360, and so on. And then if you do the range for those, we end up getting -infinity to infinity. So that's your domain and range. I wouldn't necessarily focus on memorizing those. Again, not a fan of memorizing, but if you just can think about logically that unit circle and how the domain affects the denominator, or the x values affect the denominator, you can kind of figure that out. You'll get the hang of it. Okay, and then in addition to domain and range, you have to identify the sign of the functions. So we've talked about this a little bit with reference angles when I was talking about in earlier videos, 30 degrees and 150 degrees. The 150 degrees was on the negative side, that type of thing. So there's this memory device that I think will really help you when you're figuring this out. It'll shorten the thought process, basically. And the memory device is all students take calculus, which is not necessarily true, but it's just a memory device. So if we start, this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We go counterclockwise. 1 is positive, positive. In this quadrant, all trig functions are positive, because if x is positive and y is positive, then any ratio of a positive over a positive is going to be positive. Then this one stands for S, students. Only sine functions are positive. So S, sine. And the reciprocal of sine is cosecant. So sine and cosecant are the only ones that are positive, because the y value is the only one that's positive in this quadrant. So the trig functions associated with the y values are positive. And then take is T for tangent. So tangent and cotangent are the only ones that are positive. And then calculus, C stands for cosine. So cosine and secant are the only ones that are positive. All students take calculus. And that tells you which ones are positive. All right. So based on that, I want you to figure out, you don't have to actually find it. You're just stating the sign of each trig function. So if it helps, you can draw a picture of those angles on your coordinate plane or just visualize it. So pause it, try it, come back. I've drawn very rough pictures of the angles here. And then on the left side, I have my memory device. All students take calculus. So cosine in this region is going to be negative. Cosecant in this region is going to be negative, and tangent in this region will be positive. And that's all at once. So pretty straightforward. Again, applications of that, you'll be using that when you're solving trig equations and figuring out the value of trig functions, but just to practice with the signs. Okay, cofunction identities. So using the unit circle, find the sine of 30 and the cosine of 60. Both of these are a half, and 30 and 60 degrees are called complementary angles because they add up to 90 degrees. So that's a geometry thing. And basically what I'm showing here is that when they're complementary, their trig values will be equal. So sine 30 equals cosine 60. And that leads to the cofunction identities. And you might just kind of pause and read through those real quick because we're going to use them down in the next examples. And this 90 minus theta, that's just figuring out like the complementary angle to it. So the complementary angle to 30, you do 90 minus 30 is 60. Complementary angle to 45 would be 45 and so on. So we use subtraction to find that. Unfortunately, these are on different pages here, but you're going to use that table to find the cofunction identity of each of these functions. So once you pause it, try it, come back. Using my identities, I just plugged in the values for theta, and we get sine 40, cotangent 20, and cosecant 66, and that's all at once. All right, another identity, Pythagorean identities. Recall the Pythagorean theorem. We know that is a squared plus b squared equals c squared. Now using the unit circle, write an equation for the Pythagorean theorem. So if we follow that same model, a leg squared plus a leg squared equals the hypotenuse squared. If we're talking about the unit circle, which we are, we know that the radius is 1. Then we can simplify that further and we get x squared plus y squared equals 1. Now, I also know that x is cosine and y is sine. So if I substitute that in, I get cosine theta squared plus sine theta squared equals 1. And you might see this rewritten a little bit differently where the exponent is. I have it down at the next line, but you might see this as cosine squared theta instead, sine squared theta. That means the same thing. So either one is okay. So let's use that identity to help us solve this last problem. If cosine theta is a fourth, what is the value of sine theta? Assume that theta is an angle in the first quadrant. So using the identity that we were given here, and an identity that you're going to see lots and lots, let's plug it in. If cosine is a fourth, I have cosine theta squared plus cosine squared theta plus sine squared theta equals 1. I'm sorry, my dog is distracting me. If cosine is a fourth, we don't know sine, then we can simplify that. Solve for sine. minus 16th over here. Get a common denominator with 16 over 16. Subtract. And then to undo something squared, if you remember from algebra, you take the square root. Now remember, when you take the square root, we do plus or minus, but this says that it's in the first quadrant, which means that I don't even need to consider the minus. I'm just considering the positive. And then to simplify that, I'm going to do square root of the numerator over square root of the denominator. And I get square root 15 over 4. And that's it. That's all for that problem, but something I wanted to add over here in the left, it's in pink, were some identities that I forgot to put in the notes earlier with the cofunction identities. These are called the reflection identities, I believe. I called them up here. Let me just check. Yeah, reflection identities. In case this comes up, then you might want to put those, add those in your notes. And that's all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.